Hi students, see today we are going to discuss about the chemical kinetics. It is previous year question paper 2015 to 2020 question. See, you have to mainly concentrate in this lesson, that is the rate reaction, the writing of the rate law expressions, then order of the reaction, units of the rate constant, molecularity of the reaction, then based on the first order and the zero order reaction, that is based on the numerical sum, first order using of the first order equation and the zero order reaction. Also that the first order having that half life T half also there, that is also you are going to use. See, in this part mainly the deleted part is what means for the academic year 2021 is Arrhenius equation. The Arrhenius equation is deleted part, so no need to concentrate that part. The remaining thing you have to learn. Now we will see one by one. Hi students, see today we are going to discuss about the chemical kinetic lesson, that is 2015 to 20 question paper. Mainly you have to concentrate these points. First, the rate of a chemical reaction. How to write the rate of a chemical reaction. Then units of the rate reaction. That means the first order reaction unit, second order, the zero order. They have some units. So that things you have to concentrate. Then the factors affecting the rate of the reaction. The factors affecting the rate of the reaction means what? That is temperature, concentration, catalyst. These things are factors affecting the rate of the reaction. Then the order and molecularity of the reaction. Order of the reaction, then the molecularity of the reaction. The order means zero order reaction, first order reaction, the second order reaction. So many order nth order reactions are there. You have only the zero and the first order reaction. Then the molecularity of the reaction. Then after that, the integrated rate equation. Here the first order and the zero order reaction. Basically the first order reaction based numericals comes. Then activation energy, the Arrhenius equation. This Arrhenius equation in this year, academic year 2020-21 is deleted part. So no need to study this Arrhenius equation. See, in this lesson many of the things are based on the first order kinetics, that is based on the numericals chapter. So you have to concentrate more in the numerical part. Now we will discuss the numericals. See, look at this question. For the reaction 2H2O2 gives, that is I minus iodide ion in the alkaline medium to give 2H2O plus O2. For this reaction mechanism is, first step H2O2 plus I minus gives H2O plus IO minus. This is the slow step. Then second step H2O2 plus IO minus gives H2O plus I minus plus O2. This is the fast step. The question is, write the rate law for this reaction, and the second question is, write the overall order of the reaction. Then third is, out of the two steps, step 1 and step 2, which one is the rate determining step, that is RDS. First you have to write the rate law for the reaction. So in this reaction the rate law is what? You know that the rate law is dx by dt is equal K into, here the reaction is what? H2O2, that is concentration of H2O2 into concentration of I minus. Here the H2O2, that is hydrogen peroxide, the first order reaction with respect to the concentration of hydrogen peroxide, and although the I minus also with respect to the first order reaction. So here the I minus is the catalyst, although I minus, the iodide ion is the catalyst. So this is the first question answer. Dx by dt is equal to K into concentration of H2O2 into concentration of I minus. Then second answer, write the overall order of the reaction. Here the order of the reaction, you know that sum of the reactants, the all, that's mean H2O2. So and I. For this reaction, usually you know that for this reaction is H2O2, concentration of H2O2 and concentration of I minus. So in this reactant, in the reactant side, for example, A power X into B power Y is equal to what? A power, that is concentration of A, concentration of B power X plus Y. Here this one and this one, that's mean X1 and Y also 1, that's mean 2. So the overall order of the reaction is 2. So write the overall order of the reaction is 2. That's mean second order reaction. This equation belongs to the second order reaction. Then third, out of step 1 and step 2, which one is the rate determining step? Usually you know that the slow step, you can determine the rate of the reaction. So that the first step of the reaction is rate determining step. So this is the third question answer. The first question answer is dx by dt is equal to K into concentration of H2O2 into concentration of iodide ion. Then the second question answer is overall order of the reaction is 2. That is, you have to write the second order reaction. Then third question answer is the first step. Out of step 1 and step 2, which one is the rate determining step? So here the slow step is rate determining step. So that the first step is the rate determining step. Look at this question. For a chemical reaction, reactant gives product. So variation in ln R versus time. So for this reaction, graph is given here. Predict the order of reaction. The question is, what is the order of reaction? Then second is, what is the unit of the rate constant? See, in this graph, you can see here, it gives a negative slope. So that ln R versus time, it will be a first order reaction. So the predict the order of reaction means, the first question answer is first order reaction. Then the second question, what is the unit of the rate constant? Here the first order reaction, the unit is what? Second inverse. The second question is, the second subdivision is second inverse. So this is the unit of the rate constant. So the first question answer is predict the order of reaction. From this graph, this is the first order reaction. Because of ln R versus T, that gives a negative slope, so that it gives a straight line, there is a negative slope, so that it is a first order reaction. Then what is the unit of the rate constant is S inverse, second inverse. Then this next question is, for the reaction gives, there is 2 NH3, 2 moles of ammonia gas in the presence of the platinum, then N2 gas, nitrogen gas, gives nitrogen gas and the 3 moles of hydrogen gas. For this reaction, the rate is K given. The question is, write the order and the molecularity of the reaction. Then write the unit of K. So here you can see that this is a 2 moles of the ammonia gas to gives in the presence of platinum to gives nitrogen gas and the hydrogen gas, mean it will be a 0 order reaction. So the order of reaction is 0. For this third question, this is second question, and the third question is, write the order of reaction as first subdivision 0 order, and the molecularity here to bimolecule. So molecularity of the reaction is bimolecularity or bimolecule reaction. Then the second subdivision is, write the unit of K. So 0 order unit is what? Mole liter inverse second inverse. Mole liter inverse second inverse. So this is the answer for this question. See, the next question is, for a reaction A plus B gives product. So the rate is given by the rate is equal K into concentration of A into concentration of B power 2. The question is, how is the rate of reaction affected if the concentration of B is doubled? Then second question is, what is the overall order of the reaction if A is present in the large excess? So the question, the reaction is what? A plus B gives product and the rate is given, the K into concentration of K is equal to, that is rate is equal to K into concentration of A into concentration of B power 2. So that here the concentration of B is doubled means the reaction, how is the rate of the reaction affected if the concentration of B is doubled? So concentration of B is doubled means what? Here the rate is equal to K into concentration of A and the concentration of B power 2. So how is the rate of the reaction is if affected if the concentration is B is doubled means? So here the concentration of B is doubled means it will become 4 times. So this is the answer. How is the rate of reaction affected if the concentration of B is doubled? That means B becomes the rate of reaction becomes 4 times because of the reaction is second order with respect to the B. Okay, second order reaction with respect to B. This. Then what is the overall order of the reaction if A is present in the large excess? So here this A is large excess means the reaction, the overall order of reaction is what? This is 2. So that, see, A power 0, that is B power 2. So 0 plus 2 is equal to, the overall order of the reaction is 2. Second order reaction. The second question answer is second order reaction. Because here that rate of reaction will become independent of the concentration of A. So this is the answer. See, the next question is, for the reaction A plus B gives product, the rate law is given by, the first one is rate is equal to K into concentration of A power 1 and the concentration of B power 2. Then second is rate is equal to K into concentration of A power 1 by 2, B power 2. So what is the order of the reaction? See, in this equation there is rate given. Rate is equal to what? K into concentration of A power 1, concentration of B power 2. See, the order of the reaction means what? That is the sum of powers of the concentration of the rate of the reactant. So here K into, that is A power X and B power Y. So that it will become concentration of A power B into, that is X plus Y. So here X is equal to what? 1 and Y is equal to 2. So that 1 plus 2, it will become 3. So the order of reaction, this is a third order reaction. The first question is, answer is third order reaction. Similarly, in the second one, the second one is what? A, that is 1 by 2. 1 by 2 plus this is X. Imagine this is X and B, that is 2. Y, this is 2. So it will become 2 plus 1 by 2, 2.5 order. 2.5 or you can write it 2.5 order. So this is the order of the reaction of this equation. A plus B gives product. The rate law is given there. So the first is third order reaction. The second equation, this is 2.5 order. The next question, define the following terms. The question is order of the reaction, molecularity of the reaction, rate constant, pseudo first order reaction and half-life reaction. Half-life period of a reaction. First, the order of reaction. The order of reaction, that is the sum of powers of to which the concentration terms are raised in the rate law or rate expression. I repeat that order of reaction is sum of powers to the which, that is concentration terms are raised in the rate law or rate equation, that is rate law expression or the rate equation. Then the molecularity of the reaction. The molecularity of the reaction, that is the number of the reacting species taking part in the elementary reaction which must collide simultaneously in the order to bring about a chemical reaction. The molecularity of the reaction. Usually sometimes the question order and the molecularity of the reaction. How does the order of the reaction differ from the molecularity of the reaction? Usually in a complex reaction which is taking place more than the one step. There is the order of the reaction and the molecularity of the reaction more than the one step. The order is determined with the slowest step, that is the rate determining step. So molecularity of each step is determined separately. So this is the differences between the order and the molecularity of the reaction. See, order, it can be 0, fraction, whatever it is, but molecularity never be 0. Okay. Then rate constant. Third is a rate constant. See, the rate constant is it is equal to the rate of reaction when molar concentration of the reactant is equal to unity. I will repeat this. It is equal to the rate of reaction when molar concentration of the reactants is equal to the unity. This is called a rate constant. Then pseudo first order reaction. The pseudo first order reaction is for example, the reaction which is a bimolecular but order is 1. It is called pseudo first order reaction because here one of the reactant is present in the large amount. That is why they followed pseudo first order reaction. I repeat here, the pseudo first order reaction is which is a bimolecular but order is 1. Bimolecular reaction but actually order is 1 is called pseudo first order reaction because one of the reactant is present the very large amount, that is large excess. Then half-life period of a reaction. The half-life period of a reaction, this is time in which that 50% of the reaction is completed. So the half of the reactants changes into the product. Simply they are called T half. I repeat, the half-life of a reaction is defined as the time in which 50% of the reaction is completed, that is half of the reactant changes into the product. Simply they are called, that is T half. Half-life means T half. See, look at this numerical. The decomposition of ammonia and platinum surface is zero order reaction. If rate constant K is 4 into 10 power minus 3 m per second. How long will it take to reduce the initial concentration of ammonia from 0.1 molar to 0.064 molar concentration? See, this is a zero order reaction. In the question given that zero order reaction. So that the formula is what? The rate is equal to, for zero order reaction is R naught minus, that is concentration of R naught by minus R divided by T. So this is the formula. Here what are the things given? First you have to find out. So K, the rate constant is given here, that is K is equal to what? 4 into 10 power minus 3 molar second inverse. Then R naught, this is the initial concentration. How long will it take to reduce the initial concentration of ammonia from? So 0. That is R naught, concentration of R naught, initial concentration 0.1 molar. Then this is R, that is 0.064 molar. So we want to find out the T. So how long will it take to reduce? So that long, that's mean time. So we want to find out the time. Now substitute this formula, and this is the zero order reaction formula. For a zero order reaction formula is this. So K is equal to what? 4 into 10 power minus 3. So initial concentration is 0.1 molar minus the final, that is R naught, R is 0.064 divided by T. So on rearranging this equation, T 0.1 minus 0.064 divided by 4 into 10 power minus 3. Just simplify this. So you will get, that is 0.036 divided by 4 into 10 power minus 3 mean 0.004. So it will become 9. So time, so that 9 seconds. Now the molar constant here, the unit is m second inverse. Here molar concentration, here also the molar concentration. All the molar cancel. So second inverse become second. So 9 second is the answer. See, look at this sum. The following data are obtained from the reaction, that is N2O5 gives 2 moles of NO2 plus half moles of O2. See the given value, time per second, concentration of N2O5 mole per liter. For initial concentration, that is time 0, the concentration is 1.6 into 10 power minus 2. For 300 seconds, 0.8 into 10 power minus 2. For 600 seconds, 0.4 into 10 power minus 2. Here the question is, show that it follows the first order reaction. The second is, calculate the half-life of the reaction. The given log value for log 2 is 0.3010 and log 4 is 0.6021. Now the formula is K is equal to 2.303 divided by T into log of R naught by R. First take the initial, this is initial, and the time 300 seconds and the time 600 seconds. First for 300 seconds. Here the initial concentration for this 0.8 into 10 power minus 2 and 1.6 into 10 power minus 2 and the final concentration is 0.8 into 10 power minus 2. So apply this value in this formula, 2.303, time T is 300 and log of the initial concentration R naught is what here, 1.6 into 10 power minus 2 divided by the final for 300, that means 0.8 into 10 power minus 2. Now take this for log value, 2.303 divided by 300 into log 2, 1.6 divided by 0.8, it will become log 2. Now the log 2 value is what? 2.303 divided by 300 into 0.3010 for log 2 value. Now simplify this. So the value is 2.31 into 10 power minus 3 second inverse for t 300 time 300. Next is for time 600. See, look at this answer, student. I am just writing here. There is time 300. For this, answer is 2.31 into 10 power minus 3 second inverse. Okay. Now, for t 600 time 600 seconds means just change this 600 and the initial concentration is same, that is 1.6 into 10 power minus 2, and that final concentration, that R is 0.4 instead of 0.8. So 0.4 into 10 power minus 2. Now the 10 power minus 2, 10 power minus 2 is cancelled. 1.6 divided by 0.4, it will become log 4. So the log 4 value is what here? That is given 0.6021. So 0.6021. Just simplify this, you will get the same value. So here also the same value you may get, that is 2.31 into 10 power minus 3 second inverse. So for time 300, there is 300 seconds, also the same value, and the time 600 seconds for that same value. So that it shows that the rate constant K is constant, so that it follows the first order reaction. The question is what? Show that follows the first order reaction. Time 300 shows 2.31 into 10 power minus 3 second inverse. For time 600, 2.31 into 10 power minus 3 second inverse. So it follows the first order reaction. This is proved. Second, calculate the half-life. So half-life formula is what? So T half is equal 0.693 divided by K. So K is what here? This is the K value. This is the K value. So K is same, 2.31 into 10 power minus 3. So that the answer is, just apply this formula, so 0.693 divided by K value is 2.31 into 10 power minus 3 second inverse. So simplify this. So it will become T half is 300 seconds. So this is the answer. See, look at this numerical. The following data were obtained during the first order thermal decomposition of SO2Cl2 at constant volume. See, there are two experiment results are given here. The experiment number 1, time 0, that is the initial, then total pressure is 0.4 atmosphere. Then experiment 2, 100, then the total pressure is 0.7 atmosphere. So calculate the rate constant. So K you have to calculate. So given log 2 value and log 4 value, there is 0.3010 for 2, log 2 and log 4 is 0.6021. Now first you have to write the equation. The first order thermal decomposition reaction of SO2Cl2 and undergoes, that is a thermal decomposition to form SO2 and the Cl2 gas. See here, for initial pressure initial, so this is Pi. So we don't know SO2 and Cl2. That is why 0 and 0. For pressure final as Pi initial minus X. We don't know. That is why this will be X and this will be X. So here the initial is 0. That is why time 0, SO2 is 0, everything is 0. Then after 100 seconds only this value. Now you have to write the formula, that is K is equal to 2.303 divided by T into log of Pi divided by Pi minus X. So this is the formula. Now you have to calculate, that is Pi minus X, Pi. So first the Pi you can calculate, that is P total is equal to Pi minus X. Here this is the P total, Pi minus X plus X plus X. So it will become minus X plus X cancel. So the P total is Pi minus X. So this is the answer. Now the formula is what? K is equal to 2.303 divided by that is T into log of Pi divided by Pi minus X. So here first for time 100, 0 is over, then 100, time 100. For T 100 means just apply this value in this formula, 2.303 divided by 100 log of, here the Pi, the initial pressure initial is what? 0.4, then pressure final. So the pressure final you have to calculate, that is the Pi is, that is 0.4 minus X. So we want to find out X for this. So here the P total, X you want to find out means P total is equal to Pi minus X. This is the formula. Now the P total is what? 0.7. 0.7. P initial is what? 0.4 minus X. So X becomes 0.3. X is equal to 0.3. Now apply this value in this formula, you will get 2.303 divided by 100 into log of 0.4 divided by 0.4 minus 0.3. Just simplify this. So we will get 1.386 into 10 power minus 2 second inverse. So this is the final answer. For the rate constant, here the calculate the rate constant, so that K value is 1.386 into 10 power minus 2 second inverse. See next numerical. A first order reaction takes 10 minutes for 25% decomposition. Calculate T half for the reaction. The log values are given here. Log 2 is 0.3010, log 3 is 0.4771, log 4 is 0.6021. Now the formula is K is equal to 2.303 divided by T into log of R0 by R. So finding of R. So this is the concentration, the initial concentration minus the initial concentration of what? 25%. So that 25 divided by 100 into initial concentration. So it will become what? 75 divided by 100 into R0. So 3 parts in 100, 3 parts is 75. So the 4 parts for 100, 25, that is why 3 by 4 into R0. Now for T 25% is, on rearranging this equation, 2.303 divided by K into log of R0 divided by R. So that R value is what here? 3 by 4 R naught, that is the initial concentration. So K is equal to 2.303 divided by T into log of 4 by 3. So that R naught is cancelled, so that 4 by 3. Now the T is for 10 minutes, time is 10 minutes, so that T 2.303 divided by 10 into log 4 minus log 3. So 2.303 divided by 10 into log 4 value was given already 0.6021 minus log 3 value is 0.4771. After simplifying, we will get that is K is equal to 2.303 divided by 10 into this value 0.1250. So this is the K value, rate constant value. Now for T half, calculate the T half for the reaction. So the T half for the reaction is T half is equal to 2.303 K into log of R naught divided by R naught by 2 because of 2, that is 2.303, the K value is here, substitute this K value 2.303 divided by 10 into 0.1250 into log 2, R naught are cancelled, so log 2. Now on rearranging this 2.303, just in numerator, that is this 10 becomes numerator, 2.303 into 10 divided by 2.303 into 0.1250. After simplifying, this log 2 value is 0.3010. After simplifying, we will get 3.010 divided by 0.1250. So the answer is 24.08 minute. So this is the T half for the reaction is 24.08 minute. See, the next sum is for a first order reaction, so that time required for 99% completion is twice the time required for completion of 90% reaction. So you have to prove this. So T 99% means 2.303 divided by K into log of R naught by R. So here the R value, the R naught minus 99%, so that 99% divided by 100 into initial concentration of this reaction. So that the remaining things were 1 divided by 100. So T99 is equal to 2.303 K divided by K into log of R naught divided by this term 1 by 100 into initial concentration. So 2.303 divided by K into log of this, simply after simplifying this, you will get log 100 by 1, so that is log 100. So log 100 value means 2, log 10 means 1, log 100 means 2, log 1000 means 3. So here log 100, so that 2. So 2.303 divided by K into 2. So this is for T time 99% completion. So this is equation 1. Look at this, for 90% completion of the reaction is 90%. So 90% means 2.303 divided by K into log of R naught divided by R naught minus 90 divided by 100 into R naught, because of the initial concentration is 90%. So that initial concentration minus the completion of the time, that is 90 divided by 100. So remaining is we will get, that is 10 divided by 100. So 2.303 divided by K into R naught divided by 10 divided by 100 into R naught. So 2.303 divided by K, it will become what? Log 100 by 10. So log 100 by 10, it will become log 10. So the log 10 value is what already I said, 1. So 2.303 divided by K into 1. So this is equation 2. So from equation 1 and 2, T 99% is 2.303 divided by K into 2. So for T 90 is 2.303 divided by K into 1. That means T 99 is equal to T 90% into 2. So it shows that T 99% is twice of T 90%. So it is proved. Hi students, today we were seeing so many numericals based on the first order, zero order reaction, and also the half order, T half also we were seeing. Then the definition also we were discussed here. the order of the reaction, molecularity of the reaction, rate constant, then pseudo first order reaction. So some the theoretical parts also we were seen. Just go through this video, and I hope this is very useful video for the board examination. Thank you.